Here one more problem from quadratic equations. Find all the numbers which exceeds their square root by 12. So you see all of you, let number be x. Find all numbers which exceeds their square root by 12. So here x is equal to root x plus 12 is the condition. X is equal to root x plus 12 is the condition. That is square root exceeds root x square root plus 12. Square roots by 12. So this can be written as x minus 12 is equal to root x and square on both sides. Square on both sides. Both sides. Then what is x minus 12 whole square is equal to root x. This is in the form of a minus b whole square, a square minus 2ab plus b square. By using this formula here, this is x square plus 144 minus 2 into x into 12 plus 12 square 144 is equal to x. Okay, all of you, x square minus 12x minus 12 to the 24x plus 144 is equal to x. You can take this into this side. Then what we have? X square minus 24x minus x minus 25x plus 144 equal to 0. Factorize 144. 144 is equal to 12 into 12 and 4 into 4 into 4 into 4 into 3 into 3. So this is 16 into 9. So 16 plus 9 is equal to 25. X square minus 16x minus 9x plus 144 equal to 0. X of x minus 16 minus 9 of x minus 16 equal to 0. X minus 4 into x minus 9 into x minus 16 equal to 0. X is equal to 9. X is equal to 16. Here x is equal to 9, which is less than 12. This is not correct. And x is equal to 16, which is greater than 12. So x is equal to 16 is the answer. X is equal to 16 is the answer. Okay, all of you. That's all. Thank you. Here we have one more problem from quadratic equations. Find the condition that one root of the quadratic equation ax square plus bx plus c equal to 0 shall be n times the other, where n is a positive integer. Okay, all of you. Here given quadratic equation. What is ax square plus bx plus c equal to 0? Equation 1. Let alpha comma beta are the roots. Then what is alpha plus beta? Sum of the roots minus b by a. Product of the roots alpha into beta is equal to c by a. Sum of the roots alpha plus beta is equal to minus b by a. Product of the roots alpha into beta is equal to c by a. Okay, all of you. Here and one condition is given. One root of the quadratic equation n times the other. That means let one root is alpha. Alpha is equal to n beta. Then you substitute n beta plus beta is equal to minus b by a. Beta common, 1 plus n is equal to minus b by a, and beta is equal to, this is minus b by a of 1 plus n you write. Beta is equal to minus b by a of 1 plus n. And from these two, here you write alpha into beta is equal to c by a. But what is alpha? Alpha is equal to n beta given condition. So n beta into beta is equal to c by a. Beta square is equal to c by n into a. But what is beta? Minus b by a of 1 plus n. So beta square minus b by a of 1 plus n whole square is equal to c by n into a. That is b square by a square of 1 plus n whole square is equal to c by n into a. A cancel. Then by cross multiplication, this can be written as n into b square is equal to ac into 1 plus n whole square. This is the condition where n belongs to z plus positive integer. N belongs to z plus. Okay, all of you. That is the required condition. N b square is equal to AC into 1 plus n square is the required condition. Here one more problem from quadratic equations, that is for what value of x the expression 15 plus 4x minus 3x square negative. Okay, all of you. Here you see given quadratic expression what is 15 plus 14x 4x minus 3x square can be written as minus 3x square plus 4x plus 15. Okay, all of you. You factorize this one. Minus 3 into 15. Minus 3 into 15 equal to minus 3 into 5 into 3. This is minus 9 into 4 or minus 9 into 5 or 9 into minus 5. Okay. So 9 minus 5 is 4. This can be written as minus 3x square plus 9x minus 5x plus 15. So minus 3x of x minus 3 minus 5 of x minus 3. So minus 3x minus 5 into x minus 3 are the factors. Let us you take here, this is the number line. This is the number line. So here x is equal to minus 5 by 3. This is minus 5 by 3 more than minus 1. This is minus 2. X is equal to 3. 1, 2, 3. Here you see minus 5 by 3. You can write like this. 5 by 3 more than 2. More than 2. So this is. Here f of x is equal to minus 3x minus 5 into x minus 3. Okay, all of it. So if you substitute x is equal to 3, x is equal to 3, minus 9 minus 15 minus 14, this is x is equal to minus 3, you substitute x is equal to minus 3, this is plus 9 minus 5, 9 minus 5 is positive, and this is minus 3 minus 6, so more than this one negative. So you substitute x is equal to 4. X is equal to 4. this is this is a negative and this is positive. So more than positive. So x greater than minus 5 by 3, f of x negative, and x greater than 3, f of x is negative. Means f of x is negative minus infinity to minus 5 by 3 union 3 to infinity. 3 to infinity. So in this case, this is the negative. In between these two, it is positive. Okay, all of you? That's all. We have one more problem from quadratic equation. Prove that there is a unique pair of positive, consecutive, positive odd integers such that the sum of their squares is 290 and find it. Okay, all of you? Here we have to find the roots of this one. So here consecutive, positive, odd integer. Let us you take odd integer 3, next integer 5. Difference between 2. That is, if you take one is x, other is x plus 2. Okay, all of you? So here let integer be odd integer be x, odd integer be x. Then what is other one? Other is x plus 2. Then condition is given, the sum of their squares is 290. That is x square plus x plus 2 whole square is equal to 290. Implies x square plus 4x. 4x plus 4 is equal to 290. This is 2x square plus 4x plus 4 is equal to 290. 2 as common, x square plus 2x plus 2 is equal to 290. 2 1 ja, 2 4 ja, 2 5 ja. So x square plus 2x plus 2 is equal to 145. Then what is here? This one x square plus 2x plus 2 minus 145 equal to 0. Okay, all of you? Here, this is x square plus 2x plus 1 plus 1 plus 1 minus 145 equal to 0. What is this one? Here, up to here, x plus 1 whole square. This one minus 144 equal to 0. X plus 1 whole square equal to 144. X plus 1 is equal to plus or minus 12. So x plus 1 is equal to plus 12. X is equal to 12 minus 1, 11. Then what is x plus 2 other number? 11 plus 2 is equal to 13. One number is 11, other number is 13. So x is equal to 11, x is equal x plus 2. X plus 2 is equal to 13. These two consecutive positive odd numbers. Consecutive positive odd numbers. We can't take negative value. Why? Because only we have to find positive odd integers we have to find. So consecutive positive integers, x is odd integers 11. This is 13 is the answer. Okay, all of you. That's all. Here one more problem from quadratic equation is given. Show that the roots of the equation x square minus 2px plus p square minus q square plus 2qr minus r square equal to 0 are rational, given that p, q, r are rational. Okay, all of you. Here we have, this is given quadratic equation x square minus 2px plus p square minus q square plus 2qr minus r square equal to 0. So ax square plus bx plus c equal to 0. Discriminant delta is equal to b square minus 4ac is a perfect square. Then roots are rational. Roots are rational. We know this condition. Okay, all of you. In ax square plus bx plus c equal to 0, discriminant delta b square minus 4ac is a perfect square. Then we say that roots are perfect rational numbers, otherwise irrational numbers. Okay, all of you. That's why here this is the constancy. So by comparing these two, a is equal to 1, b is equal to minus 2p, c is equal to p square minus q square plus 2qr minus r square. Then delta is equal to b square minus 4ac. B square minus 2p whole square, that is 4p square, minus 4 into a into c, p square minus q square plus 2pr minus r square. So this is 4p square minus 4p square plus 4q square plus, this is minus into minus plus, minus into plus, minus 8pr plus 4r square, minus 4p square plus 4p square cancel. Then what is delta? Delta is equal to, in this case 4 as common, 4 into q square minus 2pr 2qr 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 plus r square. Okay, so delta is equal to 4 into a square minus 2ab plus b square, q minus r whole square. So delta is equal to 2 into q minus r whole square, which is the perfect square. So perfect square. Then we say roots are rational. Therefore roots are rational. So given quadratic equation, roots are rational numbers, or rational numbers are rational. Okay, all of you. That's all. Here you see, all of you, problem from quadratic equation. If alpha comma beta are the roots of the equation ax square plus bx plus c equal to 0, then form a quadratic equation whose roots are p alpha and p beta. P is real in terms of a comma b comma p. So here we have to find quadratic equation whose roots are p alpha, p beta, and ax square plus bx plus c equal to 0 quadratic equation is given. Their roots are alpha comma beta. So from that information we have to form a quadratic equation whose roots are p alpha and p beta. Okay, all of you. So here you see, given quadratic equation ax square plus bx plus c equal to 0, equation 1. So alpha comma beta are the roots. Then alpha plus beta, sum of the roots, minus b by a, we know that product of the roots alpha into beta is equal to c by a. Okay, all of you. Then given that p alpha, p beta are the roots, then p alpha plus p beta is equal to p of alpha plus beta is equal to p of alpha plus beta is equal to minus b by a. Okay, so product of the roots alpha into beta, that is p alpha into p beta is equal to p square into alpha into beta. P square into alpha into beta is c by a, is product of the roots. This is the sum of the roots. Sum of the roots. So quadratic equation required, quadratic equation is equal to x square minus of sum of roots into x plus product of the roots equal to 0. So x square minus of sum of the roots p of minus b by a, p of minus b by a plus product of the roots p square of c by a equal to 0. A is the LCM totally, that is ax square minus into minus plus pb. So pb, okay, plus p square c equal to 0. This one cancel. Therefore required quadratic equation ax square plus pbx plus p square c equal to 0 is the required quadratic equation whose roots are p alpha comma p beta, whose roots are p alpha comma p beta. Okay, all of you, that's all. Thank you.